Using Helm charts can greatly simplify how you can deploy multiple SQL servers in containers and Kubernetes. Learn more in this episode of Data Exposed. Hi, I'm Anna Hoffman, and welcome to this episode of Data Exposed. Today, I'm joined by Amit, a program manager on the Azure Data team. Amit, thanks for joining us today. Can you tell us a little bit about what you do?
Hi, everyone. Thank you, Anna, for hosting me again on this show. Excited to be here. I'm a senior program manager with SQL Server and Linux in container space, and currently working on the niche technologies of deploying SQL Server containers and using SQL Server in DevOps production environments when it is deployed as container.
Awesome. Thanks, Amit. That's a lot of things that you work on. So we're excited to learn more about some of those things today. And, the topic for today is really about SQL Server and containers, especially when it comes to potentially having multiple replicas, maybe managing packages, and doing all sorts of other things at scale with containers and Kubernetes, maybe using even technologies like Helm, which I don't know a ton about. So I'm really just going to pass it over to you. Can you tell us a little bit more about how people should think about this and what tools are available?
Absolutely. So as you rightly said, Anna, Helm is basically the package manager for Kubernetes itself. And when we are talking today about deploying SQL Server containers in a Kubernetes environment, we really cannot be away from using Helm, because that makes a lot of deployment. It basically eases a lot of deployment options. And today what I'm going to show you is a demo of how you can run Helm on a Windows client machine and deploy SQL Server on an Azure Kubernetes environment from your local Windows machine, all through Helm. So that's something that I really want to get started with.
Awesome. I'm looking forward to learning about it.
Wonderful. So let's not waste any more time and let's get started with this. So the first thing I want to talk about is Helm and how you can use this from your Windows client. And the second thing that I'm going to talk about is some of the tools that you will need to get started with. So let's do this. Let's go deep dive and quickly see how we can all set this up and in probably less than 10-15 minutes. So to start with, what do I need to get started with Helm and Azure Kubernetes services and all of that? So the answer is you just need your laptop, which could be running a Windows operating system or any operating system, and you need an Azure subscription where you can go ahead and create an Azure Kubernetes cluster. If you do not want to use the AKS, the Azure Kubernetes service, you could also create a local Kubernetes cluster and follow exactly the same steps that we do here and have a Helm talk to your Kubernetes to deploy your SQL Server containers. So what are the tools we need? So to start with, on your Windows local machine, using which you're going to interact with your Kubernetes cluster, you'll need first to install the AZ client tool, which is the Azure client tool. Once you install the Azure client tool on your Windows machine, the next thing that you're going to install is Chocolatey, which is the package manager for Windows. And Chocolatey is another, if you've used Linux operating systems, and if you've used apt-get, yum install, all these package managers, Chocolatey is actually one of the package managers for Windows as well. Now, we are going to use Chocolatey to install Kubernetes Helm. And to install Kubernetes Helm, Chocolatey needs to be installed first. So that's why we are installing Chocolatey, followed with the installation of Kubernetes Helm. And then we install the kubectl, which is also called as kubectl, which is basically a command line to interact with your Kubernetes cluster using the Azure CLI that we install in the first step. I know you must be confused that there are a lot many steps here, but let me just tell you, it's simply 4 simple tools: AZCLI to install the kubectl, and the Chocolatey package manager to install the Kubernetes Helm. And once you have these 2 packages or 3 packages installed and running on your machine, on your Windows machine is ready to work with Helm, use the Helm chart. And I have a Helm chart available for us. Use the Helm chart and then go ahead and make the deployment on the Kubernetes cluster. So in my demo, what you're going to see is an Azure Kubernetes service as the Kubernetes cluster, and my machine, which is running Windows, as the local machine from where I'm going to run these configurations. Cool.
Awesome.
Now, with that said, Anna, I think we shouldn't be wasting any further time and probably deep dive and get started with it. So let me switch to the demo here. Okay, so we've switched to my Windows machine, and as I said, the first thing we look is if we've got the AZ CLI installed. I can quickly check that using AZ version, and this should basically print out the version of the AZ CLI that I have. And once it prints out the version, which it should, okay, there you go. So it basically means that I have AZ CLI already installed. And in the description for this video, we are going to have the blog, which basically talks about how you can do an AZ installation on a Windows machine. It's just an exe that you download, and you're good to go with that. Now, I already have the AZ CLI installed. The next thing that I want to show you is if I have Chocolatey installed or not. So I can just type Choco here, and basically it shows you that I have the Chocolatey 10.15 version already there. So Chocolatey is also installed. Again, installing Chocolatey package manager is not rocket science, honestly, because you can just open a PowerShell script and do the installation. And the link for the installation is also available in the blog. And once you have installed the AZ and the Chocolatey package manager, the next step, as I said, is installing Helm. And in my case, I've already gone ahead and installed the Helm using the command choco install Kubernetes Helm. So if I just type here Helm, you would see the different commands that are available with Helm. And as you can see, Helm is also installed. So I've just prepared my machine to save time here, but all these installations are pretty straightforward. And once you have the Helm installed, you need to also install the kubectl using the command az aks install CLI. So once you do that, this is going to install the kubectl or kubectl command. And once you do that, you need to just add the credentials, because from my local machine, I'm going to be talking to the Azure Kubernetes service. So I need to go ahead and merge the context of the Azure Kubernetes service cluster with my kubectl. And to do that, all I've got to run is the command az aks get credentials. Then I could just run resource group. So I give the resource group of where my Azure Kubernetes service is running and the name of my cluster. So here goes the resource group, and then I basically go ahead and run the name, provide the name of my Azure Kubernetes cluster. So once I do this, that's going to go ahead and merge the credentials so that I can go ahead and run a command, something like kubectl get all, and this is going to go ahead and connect to my Azure Kubernetes service and give me the current output that you're basically looking at. So I could just take a look at the different nodes. So again, I've just set up a plain simple 2-node Azure Kubernetes cluster running for us. So with the installation of tools done and all of that taken care, now it's time for us to go ahead and run the Helm installation. So what I'm going to do is I'm going to say Helm install, and then I just say MSSQL hyphen accept some of the parameters and go ahead and start deploying. Now take a look at this, how simple the deployment here is. So I'm basically going ahead and deploying 3 SQL Server instances, all using their own PVCs, which means all of them are using their own storage. And all the three SQL Server instances will also have the MS SQL config file attached to them with basic configurations set, and it's given to all the three SQL Server installations. So when I run this command, what you're going to look at right now, before I run this, I think I should first show you that right now I don't have any resources at all in my environment. And now I can just go ahead and run the command helm install and the rest of the command. Let me just type that. And if I just go ahead and click enter, you should see the deployment coming up. So if I just show you get pods, and we'll just watch just to see the container creation. I'll just put this window in the side here, and let me just open the chart that we are using. Again, the details about this chart will be made available, but I really want to quickly focus on what we are doing here. We have templates created here. So you can see one of the containers already running.
Wow.
So one of the SQL Server instances already deployed. And here are some of my deployment files. Now, I'm not going to go way too much in depth on the deployment file, because that's going to be another topic in itself. But while the second container is going to be up, let's just quickly take a look at the current deployment YAML file. So as you can see, this is my deployment file. And if you see, SQL Server is a stateful application, right? It's not a stateless application. You need SQL Server to persist the values, the data, the transactions that were going on when the SQL Server is restarted, even if the SQL Server is restarted. So
Right.
SQL Server is a stateful set application. And that is why in this deployment, we are not using the normal deployment that you might have seen all across, which basically says the kind as a deployment, but rather we are deploying it as a stateful set. And if you look, we are providing a configuration file itself, the MS SQL config file itself as a file, and mounting it. And we are also going ahead and mounting the data drive that is required. We also have the SA password secret that is set up on my Kubernetes cluster. And I'm passing most of my values to the variables here through the values YAML file. And this is where, as a user, once you have access to these deployment files, which I'm going to be uploading and sharing the details, you can go ahead, change this. So let's say in your environment, you need, let's say, 5 deployments of SQL Server. You can just change this value to 5. You want to not install 2019 latest, but probably a 2019 CU6 or probably a CU5 for certain reason. You could change that. And you want not a developer edition or different editions, you could do that. Or you could add any further values that you need. So this is the values YAML file where you can actually configure it and do the installation without being troubled to look what is basically happening here.
Right.
So as a user, it makes your life very, very comfortable. And the last part that I want to talk about is the MS SQL config YAML file as well. So this is the normal configuration that I want my SQL Server that is installed in the container or in the Kubernetes to have. So I want the AG to be enabled. I want to accept the EULA. I want the mini dumps to be enabled. So you can, again, as a user, you can go add the other values that you want. For example, you want to enable AD authentication. You could add your key tab entries and all of that here, right? That we discussed in our previous video. So you could do those settings out here, and all your SQL Server instances that are going to get started will have this thing. So remember, this is a stateful deployment. This is not a normal deployment that you're doing for SQL Server.
Right. And it's really important that your SQL Server is stable because you don't want to lose any of those transactions. And I mean, you know, when you were showing us this, it looked like you were deploying several replicas. And, you know, I'm still kind of new to Kubernetes. How does this compare to like an always on availability group?
Awesome. Good question, Anna. So let's say that so these are 3 different SQL Server instances running on the same Kubernetes cluster. Now, I want to do a 3 instances of SQL Server deployed, and then I want to set up, let's say, always on top of these 3 instances. I can do that without the need of doing manual installation or deploying containers one at a time. So I would go ahead and probably create 2 YAML files, one for the primary, one for the secondary, so that I can run primary on a specific node of the cluster and secondaries on the other node of the cluster, so that I get node, I get the node does not remain a single point of failure. And then I could go ahead and deploy SQL Server or always on top of those 3 instances in a read scale mode. Because remember, today, Anna, we support always on containers in a read-only mode at this point of time. We don't support it as cluster type, as external for some more time. I mean, there are going to be few exciting announcements very soon, but for now, we do not support it. But maybe probably in our next video, we could also talk about how we can set it up, mirroring on top of these 3 containers.
Cool, awesome. Well, it was certainly much faster to deploy those 3 than anytime I've ever tried to deploy through SQL servers.
Yep. So let's just take a look and see if, because I can see all the 3 pods up and running here. So there you go. Let's quickly see. So can you see here? We have 3 SQL Server instances already up and running. And remember, this is a stateful deployment, so you need to have a headless service that's created, which will not expose these SQL Server instances outside the cluster. Now, this is going to be bad, right? I mean, how would a DBA then connect to the SQL Server instances? So how do we solve this problem? And for this, we basically have something called as the load balancer service that we need to create. And this is what you'll see here. We are going ahead using, for each pod, we are basically giving a load balancer service, so that if this pod starts on another node, still the IP address, the port, everything remains the same, and you can go ahead and connect to the SQL Server without even knowing that the pod was probably deleted and recreated on another node. So let's quickly just go ahead and do that. And for that, what I'm going to do is, and don't worry, we are going to share these scripts, so you can definitely take a look at this after the video as well. So let me just quickly copy this location, and let's kubectl and the basic command here. So using Helm, we deployed the 3 SQL Server instances, and using the kubectl command, I'm just going to deploy the load balancer services for each of these instances, so I can connect from outside the Kubernetes cluster. And the command is pretty much this. And once I do that, there you go. Now just take a look at the services. You can see 3 services all up and running. So as a DBA, now I can just go ahead. So this is my local machine, remember? So I can just go ahead and open SSMS or Azure Data Studio, whichever tool you like, and give in the password. Of course, I'm not going to say what the password is. And just connect to it. Okay, I should connect until I've just messed up the password.
So the load balancer is what's going to give us something to actually connect to. So this is a little bit different from normal SQL Server, but it should be pretty standard for Linux and container people.
Yes, it is. In fact, this is basically how you would go ahead and connect to the SQL Server. You know what? Let me just cancel this. Let's just go back and let's ensure that I did copy it right. So Control-C, Control-V.
One more question while this is loading. Is it important to specify the ports which you connect to when you connect in this way, or does it just kind of know, does the load balancer take care of how to do that?
Yes. So if you look at the service YAML that we have, we've specified the ports. Now, if you don't want SQL Server, and of course in production environment, you wouldn't want SQL Server to be listening to the default port. So you will be making those changes. At that point of time, you will have to specify the the port on which you want your SQL Server to be running, of course, the same value has to also be specified in the MS SQL config, right? Because you're changing the port number. So you don't have to mention that during connectivity, but in the YAML files when you're configuring the services.
Gotcha.
Okay,
Cool.
awesome. All right, Anna. So look, we just did a small mistake there, because what we were trying to connect is to the cluster IP address, and that's not going to work, because that's always going to work for internal connectivity. So if I want to connect as a user or as a DBA, if I want to connect to my SQL Server instance, I need to go ahead and use the external IP. And so I copy this address here now and take a look at the port mapping here. So you can see it's the port mapping. So if I want to change this port, I go to my YAML file that I showed you, which is the service YAML file, and change the port there, and make sure that you also add that entry in your MS SQL config options as well. Okay, let's see if we've successfully resolved the issue. So let's give the same password. There you go. So
there you go.
Now see, we're connected to a SQL Server. And as I said, this SQL Server instance already should have always on also enabled. So if I click on this, I shouldn't get an error. Yeah, so there you go. I don't get an error, and I can go ahead and create always on if required. And similarly, to connect to other SQL Server instances, I just need to go ahead. Again, remember, copy the external IP address, provide in the password for SA. Again, you might ask, where did we give the SA password? I've already saved that in my Cube cluster by using the command. I can just show that to you. Secrets. So when I take a look at this, so this is the secret that I've already using, and this is what I'm giving as the password here. So you can just connect to that. There you go. So if I just say new query and take a look at what the name of the server is, you're going to see the pod name as the server name. So there you go. And for a DBA, this is no different than managing a normal SQL server that he would or she would.
Right, because at the end of the day, it's just SQL Server. It's just running in a different place than some folks are familiar.
Yes, absolutely. So as you can see, I don't know if this is way too small a font. So let me just in font here. So this is my pod name here, and this is my server name as well. So if I go ahead and stop or delete this and recreate it, the IP address is still not going to change. The name is still not going to be changing. So everything remains intact even after it restarts. And just last thing that I want to just show you. So I can exec inside the pod and say I want to run bash, and I want to read the MS SQL configuration file, because I want to see did it take all the configurations that I passed through the Helm chart. It should, but let's just take a look at it. There you go. So this is exactly the values that we have, which
right. So that's what we saw in the YAML file, which you use Helm to then deploy.
Yes, absolutely.
Cool. So that Helm takes care of kind of like packaging all your recipes or scripts together and then deploying and managing them for you.
Absolutely. And so with just 2 lines of command, I was basically able to deploy SQL Server containers, 3 SQL Server instances, all running on their own PVCs, using their own storage, and also created an external service on the cluster so that I can access it outside the cluster, all with just 2 lines of command. That's the package manager Helm that can do for SQL container deployments when you want to do it in large-scale production environments.
Awesome. That's really cool. This has been really interesting. I've learned a lot. I had never seen Helm before today. So thanks for sharing it with us, Amit. For our viewers that are new to this, any resources or tips that you have for folks to get started?
Oh, yes, absolutely. And the first thing that I basically would want them to go take a look at is, because how did I get started with this? So, one of our colleagues just reached out to me asking that exact same question, that they were new to Kubernetes and Linux world and didn't know Helm, and they wanted to go ahead and get started and see how quick they can learn. And they finished learning all of this in less than a day, just by doing it all by themselves. And here is a simple follow along plan that I have, which will help you deploy Azure Kubernetes using Helm chart. So all of this, what we've discussed, is documented. But in this case, the chart is going to deploy a normal deployment. For stateful deployment, I'm going to soon write another blog, and you can use that chart, which I just showed here. You can use that, and you can do a stateful deployment as well.
Awesome. Well, this has been great, Amit. Thanks so much. To our viewers, we will put a link in our description to this blog post and any future blog posts that Amit writes on this topic. Again, Amit, thanks so much for joining us. For our viewers, thanks for tuning in. If you like this video, please like this video, leave us a comment on what you think of using Helm charts, and we hope to see you next time on Data Exposed.